In the Python program provided for sales forecasting, most of the essential functionality for processing and analyzing data, as well as for implementing a deep neural network, DNN, is encapsulated in the libraries and functions that have been loaded. These libraries include pandas, numpy, and statsmodels, which offer powerful tools for data manipulation, numerical operations, and time series analysis, including the ARIMA model. Pradeep K. Suri, author and researcher. The DNN concept, as mentioned earlier in the conversation, is not a component of this specific program. The program focuses on time series analysis and forecasting, which is typically addressed using statistical models like ARIMA. If you want to use a DNN for forecasting, you would need to create and configure the DNN architecture, including the input and output layers, and train the model accordingly. You might use deep learning libraries such as TensorFlow or PyTorch for this purpose. The specifics of defining the architecture and training the DNN would depend on your data and forecasting requirements. In summary, the Python program provided in this conversation is focused on time series analysis and forecasting using an ARIMA model. If you wish to use a deep neural network, DNN, for forecasting, you would need to design and train the DNN separately using appropriate deep learning libraries and techniques. The ARIMA, autoregressive integrated moving average, model is a popular time series forecasting model used in statistics and econometrics. It's designed to analyze and predict future values in a time series data sequence, which consists of data points collected at specific time intervals. The ARIMA model comprises three key components, as reflected in its name. 1. Autoregressive, AR. This component models the relationship between a data point and a linear combination of its previous values. It assumes that the current value depends on its own past values. 2. Integrated, The integrated component refers to the differencing of the time series data. It is used to make the data stationary, which is a fundamental assumption in time series analysis. Stationary data has a constant mean and variance, making it easier to model. Differencing is employed to remove trends and seasonality from the data. 3. Moving average, The moving average component captures the dependency between the current value and the past prediction errors, residuals, in the time series. It models the influence of past white noise, random error, terms on the current value. An ARIMA model is typically represented by three parameters, P, D, Q, where P represents the order of the autoregressive component, AR, and signifies the number of past observations used in the model. D represents the order of differencing, I, and indicates how many times the data has been differenced to achieve stationarity. Q represents the order of the moving average component, MA, and signifies the number of past prediction errors included in the model. ARIMA models are valuable for modeling and forecasting time series data that exhibit various patterns and dependencies over time. They have applications in fields such as finance, economics, epidemiology, and environmental science, among others. To apply ARIMA effectively, you often need to select appropriate values for the P, D, Q parameters through analysis, model fitting, and evaluation. You can use software libraries like statsmodels in Python to implement ARIMA models for time series analysis and forecasting. Thanks.